Hi everyone. In this lesson we're going to learn about similar figures, their properties, and scale factors. Similar figures are figures that have the same shape but different size. And the symbol for similarity is the tilde symbol. So if you notice carefully, same shape but different size, those are the properties of the figures that are created whenever we do dilations. So basically, whenever we work with dilations, we are working with similar figures. Remember, dilations are the only transformations that create figures that are different in size because dilations are not rigid motions. There are two properties for similar figures, and they are here. Corresponding angles are congruent and corresponding sides are proportional. So corresponding angles being congruent, for example, if I have this pair of figures and they are similar, then C would be congruent to C prime, which is the corresponding angle to C. B would be congruent to B prime, and A would be congruent to A prime. The second property, corresponding sides are proportional. First, we need to remember what a proportion is. And a proportion is simply something like this. What is it? It's simply an equation that says that two ratios are equal. So it means that with the corresponding sides of similar figures, you could write proportions because the ratio of any corresponding sides should be equal to the ratio of another pair of corresponding sides. For example, if I write a ratio with AB, which corresponds to A prime, B prime, that ratio should be equal to the ratio that I write with AC and A prime, C prime. And that is also true for the other one. Those ratios should also be equal to the ratio of BC and B prime, C prime. Because if the ratios are equal, only if they are equal, we can write proportions. So in this case, if we write a ratio, let's say with these corresponding sides, AB over A prime, B prime, that ratio should be equal to the ratio that I could write with these other corresponding sides, AC over A prime, C prime, and that should also be equal to the ratio that I could write with the other corresponding sides that are left, which are BC over B prime, C prime. So whenever you write a proportion, you only need two ratios. You don't need all of them three. So you could write this proportion using the two first ratios, or you could write a proportion using the last two ratios that you could see here, or you could write a proportion using the first and the last, but you only need two ratios being equal because that is a proportion. So if that is the case, we could say that triangle ABC is similar to triangle A prime, B prime, C prime. The only thing is that we're not going to be saying A prime, B prime, C prime. They could have different names It doesn't necessarily use the primes of the original names. Number two, the scale factor is the ratio of a length in the image to the corresponding length in the preimage. Scale factors are what are used in dilations in order to create the new figure, the image. So we use the scale factors before. The scale factor is usually represented with the letter K, but this is just a letter, a variable, so it could actually be used any other letter to represent the scale factor. So I'm going to use K. The scale factor is a ratio, and it's a very specific ratio. It's a ratio of a length in the image to the length in the preimage. Here what it says 2, that is what divides the numerator and the denominator of the ratio, so that whatever comes before 2 is the numerator and whatever comes after 2 is the denominator. So a length from the image goes on the numerator always, and the corresponding length from the preimage goes on the denominator always. So the scale factor is very specific, image over preimage. But if you're simply writing proportions with corresponding size like this, it really doesn't matter which one is the image and which one is the preimage, who goes in the top and who goes in the bottom. It doesn't matter. You just need to write a proportion using corresponding sides. But if you are writing or if you are finding a scale factor, it's very specific. The ratio is very specific. So there's some things that you need to be able to do when working with similar figures, and one of them is to find the scale factor. And that is what we're going to do for exercises 1 and 2. It says the figures are similar, find the scale factor. So we need to remember, first of all, that a scale factor is very specific, is the ratio with a length from the image on the numerator and a length from the preimage on the denominator. So the first thing that you need to do when trying to find a scale factor is determine which one is the image and which one is the preimage. So in number 1, we have this figure, which is actually a dilation in the coordinate plane. It's a dilation where the center is the origin. So which one is the preimage and which one is the image? That's the question. And in this case, we can actually identify very easily because we know that the image is the ones that have the prime symbol. And so we have here P prime, N prime, N prime, and O prime. So this figure is the image. And the big figure is the preimage or the original. So this is the new figure. This is the image. And what we want now is a length from the image. Any length, but in this case actually the only length that I could actually find very easily is this length here of side O prime P prime, because we can just count the units and we have 5 units for the length of O prime P prime, so it's 5. So when we write our scale factor, this length, which corresponds to the image, goes on the numerator, and the corresponding length would be obviously this side, and if you count the units, that is 15 units. And the 15 goes here on the denominator. Of course, you can always simplify this And in simplest form, this would be 1/3. So this is the scale factor that was used to create the image, given that you have the pre-image. Remember the importance of scale factors. The scale factors are related very closely to the two figures in their lengths. For example, any length in the pre-image, in the image, any length in the image would be 1/3 of the original length in the pre-image. And we can see it here very easily. O prime P prime is 1/3 of the length of OP. So O prime P prime is 1/3 of OP. So the length of O prime P prime is 1/3 of the length of OP. And that is true not only for this pair of corresponding sides, but also for all the pairs of corresponding sides. That is what the scale factor means. And that is true not only for the corresponding sides, but actually for any length. For example, if we take the length from the center of dilation, which is in this case the origin 0, 0, if we take the length from the center of dilation to any point, let's say O prime, that length should also be 1/3 of the length from the center of dilation to the corresponding vertex of O prime, which would be O. So the length from the center of dilation to O prime is 1/3 of the length from the center of dilation to O. And that will be true for any other point on the figure. So we have our scale factor for number 1. We're just going to do it for number 2. And if we notice here, we are not working with the sides of the figure. We are only working with the length from the center of dilation to the figure, or the distance from the center of dilation to the figure, and the distance from the center of dilation to the other figure. So very important, we need to identify, first of all, which one is the image. And in this case, we know that the bigger one here is the image because it has P prime, whereas the other only has P. So this one is the image. And now we can write our scale factor. We're taking now the length or the distance from the center of dilation to the image, which is 10. To the corresponding length from the center of dilation to the pre-image, which in this case is 4. And we can simplify this. This is 5/2, which is equivalent to 2.5. And we could actually here also review from the dilations, if the scale factor is bigger than 1, we have an enlargement, and you could see that the original figure was small and it got bigger, so we got an enlargement here because the scale factor is bigger than 1. Okay, greater than 1, we have an enlargement. In the first one, we have a scale factor that is small, between 0 and 1, it's less than 1. And in this case, we got a reduction. The original was bigger and the new one is smaller. That is what we call a reduction. And that happens when the scale factor is between 0 and 1. We now go to exercises 3 and 4. So the next thing that you should be able to do when working with similar figures is finding lengths of sides. The instructions say the figures below are similar. Find the length represented by the variable. In this case, we're going to be using the proportion because we know that if the figures are similar, then the corresponding sides are proportional. You can write proportions with corresponding sides. For number 1, we have to find the length that is represented with the variable n. And we're going to be setting up a proportion with corresponding sides. We need to find n, so we need to use this side and the corresponding one in the other figure, which obviously is going to be side YZ. So we write our ratio n over 25. And then we write our second ratio using another pair of corresponding sides. The only pair or the only side whose measure is known in the first figure is UT, so we have to use this one. And we need from the other figure the corresponding side to UT. UT is the longest side in this figure, so we need to use the longest side on the other figure, which is going to be XY. And when we write our second ratio, we have to be careful on how we write it, because the second ratio has to be written in exactly the same way as the first ratio. So in the first ratio, we have this situation. We wrote the length from the small one, from the small figure, over the length of the big figure, and that is the same way that you should write the second ratio. So that's the only thing that you have to pay attention here. So from the small to the big, 21 over 35. Here is not really important which one is the image, which one is the pre-image. We actually have no way to know it either. And so we need to write a proportion using corresponding sides. It doesn't matter which one goes on the top, which one goes in the bottom. You could put big on the top and then small in the bottom, but both proportions have to be formed in the same way. That's the only thing that you have to pay attention here. And then how do we solve proportions? From algebra, we simply cross multiply. So it will be 35 times n equal to 25 times 21. This is 35n equal to 25 times 21 is 525. And then we solve for n by dividing by 35. So n is equal to 15. And that is how we find that the length of the side that we were looking for is 15 units. You can always check if it is correct or not. Remember that the ratios of corresponding sides in similar figures must all be equal. So if I take this 15 and I make the ratio with the corresponding side, 15 over 25, that should be equal to the ratio of the other corresponding sides, like 21 over 35. So if we simplify this ratio, 15 over 25, that will be equal to, simplifying this, 3 over 5, because both numbers are divisible by 5. And in this case, both numbers are divisible by 7, so we can take the 7th part of each one, and that would leave 3 over 5 as well. So both ratios are equal, and that is good because that is how it should be for all pairs of corresponding sides. The ratios should be equal. In our last problem, we have something similar. We had to find the length represented by the variable y. And since we had to find y, we need to use from the other figure the longest side, because this is the longest side, so we need to use this 84. Those are one pair of corresponding sides. And then we have 25. That's the medium side in the second figure, so it has to be 70 here. And then we just write our proportion using corresponding sides. So we could write 84 over the corresponding side, which is y, 70 over the corresponding side, which is 25, cross multiply and solve for y. So that is 70y equal to 84 times 25, that is 2,100. We divide by 70. And y is equal to 30. The value of y is 30, and you can check by doing the ratios to see if the ratios are the same or are equal for both pairs of corresponding sides that we have. And we could actually find the other side also. For example, if you were given x, then in this case you will have to use the short side and the x and what was given originally, which is the 70 and the 25. Let me just double check, because it seems like there is something that is not making a lot of sense. So I'm gonna double check very quickly the work that I did here. So I should multiply 84 times 25, that is 2,100, and then I need to divide by 70, that is 30. Okay, so I was just checking to see if the ratios of corresponding sides are equal, like in this exercise, and I didn't get it. So now I did it one more time, and I got it, so everything is correct. And I was saying you could also find the value of x, so you could have more than one variable that you need to find, but you must have at least one side, so you could have one complete ratio in order to find the other variable. So that's it for today on using similar figures and finding the scale factor and also finding the length of sides of the figure.